Alright, got a question about how to make a slot hole adaptive to a round hole. Whenever the round hole position is moved, the slot hole will follow. So let's make a couple parts here. Gonna make it out of sheet metal because that's probably what we'll be using it for. So gonna make a little sketch here, and 10 by 2. Okay, put a couple of random arbitrary holes, and let's make them all the same. In line with each other, and vertical with each other. Okay, try and get away with as little constraints as you can, so we're fully constrained. And just for good measure, let's put one in the middle. Little hotkey here, set up equals. Alright, so end our sketch, and let's make our face. Alright, go to our defaults, make sure that we're at something that's usable. I don't have any of my stuff set up here yet. Put an 8th. Save and close. Alright, here's our part. Save. Now, right now, it's generic. Let's make this steel. Mild? Sure. Okay. Save. New assembly. Let's place our new part that we just made. Okay. There we go. Now, he wants to make an adaptive part, so let's make a part from the assembly level, okay, on that face. Let's create a sketch on that face. Alright, let's project our geometry. So, now we have all that stuff. Let's make our slots. Easy enough. Equals. It's nice to set up the hotkeys. Makes it a little bit easier. I use them all the time. Saves me a lot of clicking and reaching for other places. Having to find everything. Just kidding. Alright. Okay. Alright, fully constrained. Now let's pretend that one, let's offset that at quarter. Alright, so we're done. Now, I always forget, convert this to sheet metal. Let's make a face. There's our face. Make sure our defaults are set up. Okay, so there's our part. You can see the adaptivity to there. So when we return, there we go. Now you will have an adaptive part. It'll have a couple of constraints that are set up. So they can still move around because this back part is not rooted or grounded or anything. So they can both move around, but they're basically with each other. Personally, I don't really like to use adaptive parts all that often. It gets me into trouble just because I've been using it for a while and I know enough to get myself into trouble. So a better way, in my opinion, is to do it a different way. So first off, take this part. It's got, floating around, ground and rooted. Sticks it right to the origin. So we have our origin here, here, and here. That's where it's flush to. So now it won't move around, so it's good. Alright, so let's make a new part. Make it sheet metal so didn't mess up like the other one. Alright, derive the part. I like the derive. So find our new part for 18. Here we go. make it a surface. So basically we're just referencing its existence. So that way we can use all of its geometry, but we're actually not using the part. If you use patterns or other distances, you can use those for parametric modeling, and really helps it out. So you can use your parameters, your sketches, reference all sorts of things. So it's good. So for right now, all we need is the actual body itself for this. So now we got it here. Let's create a sketch on the face and pretty much do the exact same thing that we had before. Adaptive parts and derived parts are very similar. I just prefer derived parts. So make our slots real quick. And I think I missed one in there somewhere. Okay, fully constrained. All right, you can turn all this stuff off if you want, but that's just kind of up to you. It's face. Just more things to click if you don't make them construction lines. Nice thing about the drive part, now it sticks the thickness, so when you make the new part, it should stay. It doesn't always. I would recommend always checking your sheet metal defaults, because if you do not, you'll get yourself into some fun trouble. So here's our drive part. Notice how this is the actual part level. It's not into the assembly level, and you still see the part here. That's because it's actually referenced. So you basically turn that visibility off. If you referenced any other geometry, like the dimensions or the sketches, they will be in here too. You can turn those off as far as the visibility goes. It's real nice. So save our part, close it out. Here's our assembly. Let's place our part. There we are. Open that up. So it doesn't matter where we put it. This one's grounded. This one's free to float around. It has no constraints to it. It's just our part with our stuff. So grab this guy, ground and root. So that way they are exactly stuck together on the way that they were built. So if you derive a part, it will know that this part is on this part on those dimensions. So that way you don't have to mess around with any flush constraints. If you mess something up, it'll pretty much stay where it's supposed to be. All the times you'll get out of hand and forget where things are, ruin constraints. This way it's easier to drive parts. So if you wanted to change something, let's say on part 18, just open it up. You'll still see the other one in the assembly environment. Change this. Let's make it 5, 5, 4. Okay? So, there we go. There you go. All of our parts are the same, and they update. There's no adaptive parts, there's no links, there's no constraints. Everything is just sticks together. You just ground them and root them. With drive parts, it's a lot easier than the adaptive parts. There you go. There's our assembly, and they will stick together. Last thing, let's go into here. Change this to, say, 3/8, make it real big. Oh, apparently I made them too big. There we go. Alrighty. Holes, slots, sticking together. Thanks.